We've talked about direct and inverse relationships before, but today let's talk about how you would write an equation for either direct or inverse relationships. First, let's recall what even are direct and inverse relationships. Well, remember for direct, essentially what we're doing is we're saying that x and y are both going to go up or they're both going to go down according to some constant value. A very common example for this is how long you've been driving and how far you go. So I could write something like this. My distance equals some constant multiplied by my time. And as my time goes up, my distance is going to go up. So this would be an example of a direct variation equation. A more common form of a direct variation equation is to use the variables y and x, and you'll see something like I have written here, y varies directly as x. So that equation specifically looks like this. Y varies directly means equals some constant multiplied by x. And as x increases, your y is going to increase. It also works in reverse. Maybe your x is going to be decreasing, then your y will be decreasing as well. Now, inverse variation is the opposite. We have one thing increasing and the other thing decreasing. So maybe you're sharing a bunch of cookies with friends. You've got 10 cookies and a few friends, and you're going to divide up these cookies among your friends. So how much cookie everybody gets depends on how many friends you have. So the amount of cookie that everybody's getting is going to be however many cookies you have divided by however many friends you're sharing it with. Now you can imagine as that number of friends increases, the amount that everybody's getting is going to go down. Or as your number of friends goes down, the amount of cookies that everybody gets is going to go up. This is called an inverse relationship. And again, most commonly, you're going to see this represented with y and x. So in number 2 here, I have that statement y varies inversely as x. So that would be y varies inversely means some constant divided by whatever follows, which in this case is x. So I have direct on the left and inverse on the right. Your k for both direct and inverse will not change for the entire question. It's constant. Once you find it for that question, it's not going to change. But your x and your y can change. Just like we talked about, maybe you have more friends, maybe you have less friends. Those x and y values are going to change depending on each other. But your k value is going to stay the same for the whole question. So let's take a look at this one. If y varies directly as x, that means I'm going to have the equation y equals k times x. And that, again, is just from this first statement where y varies directly as x. So I know that y is equal to some constant multiplied by x. And they give me the scenario, y is 14 when x is 2. They want me to find the value of y when x is negative 3. So the whole reason they give me this first scenario, if y is 14 when x is 2, is so that I can find my k value. Because remember, k, once I know what it is going to be the same for the entire question. So I can plug in my 14 for y and my 2 for x and solve for k. Now that I know what k is, I know what my direct variation equation is. My equation is going to be y equals 7x for every x and y ordered pair. So I can use this now to answer the question that they're actually asking, which is, what is the value of y when x is negative 3? So all I need to do then is plug in a negative 3 for my x and simplify. Y equals negative 21. And that's all. Let's go ahead and look at another one. Here, y varies inversely as x. So I'm going to take that first sentence and write my inverse relationship equation. Y varies inversely means equals a constant divided by whatever follows, which is x. So once I find k, it's going to be the same value for the entire question. So then that scenario that they give me next, y is 4 when x is negative 6, that can help me find my k value. My y is going to be 4 and my x is negative 6. I can solve for k by multiplying and simplifying. Since k is negative 24, I can go ahead and write my inverse variation equation, and this is the equation that I'm going to use for every scenario in this question. So what they want to know is what happens to y when x is 8. So now I go ahead, I take my equation, and I'm going to plug in an 8 for my x and see what y is. Dividing on that right-hand side, y is negative 3, and there we go. 2 more. Now, if you're feeling good, go ahead and pause the video and try them on your own, but I'll go ahead and work through them as well if you would like to follow along. So number 1, y varies directly as x. So y equals k times x. Y is 10 when x is 15. So I'll go ahead and put my 10 and my 15 in and solve for k. Here, k is a fraction, but that's fine. K is 2/3, which means that my equation is y equals 2/3 times x. Now, what's the value of y when x is negative 6? I'll go ahead and put a negative 6. To multiply, I can put this as negative 6 over 1. So then y is equal to negative 12 over 3, which is negative 4. So y is negative 4 for question number 1. Let's go ahead and look at question 2. Y varies inversely as x, so y equals k divided by x, and y is 1/2 when x is 12. So on the left, I have 1/2 equals k over 12. Multiplying by 12, I can isolate my k, and I find that half of 12 is 6, so k is 6, meaning that my equation is y equals 6 over x. So the question that we're actually concerned with is what is the value of y when x equals 9? So I'll go ahead and throw my 9 into x and simplify. I can reduce 6 and 9 by 3, giving me 2/3. So that is my y value. And that's it. Hopefully that helped. Thanks for watching, and I'll see you next time. Bye.